Hello, good morning, students. How are you? Is everything okay? Let me check whether am I audible or not. Okay. So yes, we are audible. Sorry, I am audible. Now let's just start. In the previous class, what you have studied about graphs, the xt graph, vt graph, and the acceleration time graph. Now in this session, we will start with some kinematic equations, motion under gravity, motion along the horizontal line. That's all we will study in this chapter, in this particular lecture, actually. So, first of all, we will recall some previous things. Okay, okay. So, in the previous class, you have studied about the graphs. So, in this table, I am asking you, or I am going to ask you, that what to be filled in the term in the table. Like there is a column of slope, there is a column of area. Slope means, what is the meaning? That slope of xt graph gives what? That you need to fill in this column, and slope of vt graph gives what you need to fill in this column. That's what I am saying. Is it clear to everyone? What is the task that you are assigned with? Clear. So let's start. First of all, I will ask you, let's suppose this is xt graph. Then what is the meaning of this slope? Slope of xt graph is nothing but a dx over a dt. Slope of xt graph is dx over a dt. What it will give, everybody remembers from the first lecture that dx over dt is nothing but the velocity. That means slope of xt graph gives us the velocity. In the same way, if I ask about what is the slope of vt graph, how you will write it as? You can write it as dv over dt. And everybody knows that dv over dt is nothing but acceleration. dv over dt is nothing but acceleration. Similarly, if I talk about acceleration, this is what you can say, dA over dt. And this dA over dt is nothing. It gives nothing. That means slope of xt graph gives velocity, slope of vt graph gives acceleration, and slope of acceleration time graph gives nothing to us. Is it clear? Now, for example, I'm talking about now area. So I will start, for example, let's say this is xt graph. Try to be attentive in the class. This is xt graph. And if this is the xt graph, let's suppose this is the graph, something. Then area will be what? If you draw some very small portion, this rectangular kind of strip, this is dt, and let's suppose this is x. So what is area? Area is integration x dt. So what I can write here, that area is given as integral x dt. And this integral x dt gives us nothing. So that means area under the xt curve is not important to us. But the thing that you should remember, that how area is written as, x dt. Similarly, if I talk about vt curve, area can be written as integral v dt. And if I talk about acceleration time graph, area can be written as integral a dt. Clear? Now you have to fill the table. And if I say, just fill about area of the vt curve is equals to integral v dt, and what it will give. Can anyone answer? JNV Bhavnagar, can you answer? What it will give area under the VT curve? Area under the VT curve gives us what? Displacement. Gives us displacement. Similarly, area under the AT curve, how you can write the area is equals to integral A dt, and this integral A dt gives us change in velocity. Change in velocity. So this is the table that you should remember all the time. This is the revision of the previous class, which is most important for us. Now, in this class, just do one question, and after that, we will start with some today's topic. So there is a question for you, and you should answer the question. You have some 30 seconds to answer the question. Okay, first of all, say yes or no whether am I audible to you or not. Okay, so just read the question. Question says the acceleration time graph of a particle moving in a straight line is shown. So this is the acceleration time graph they have given. At this point, acceleration is given as 10 meter per second square, and at this point, this is the time t equals to 4 seconds. This is t equals to 4 seconds. Now, at what time particle again acquires its initial velocity? Now the picture is something like that. Particle is moving, starting with some velocity at t equals to 0, and again regains its same velocity. That means that final and initial velocities are same. So according to the question, if I say that final velocity minus initial velocity, that means if you take a difference of these two velocities, it should be 0, because particle is again gaining its same initial velocity. That means the difference of the two velocities is 0. Now, what is the change in velocity? From the acceleration time graph on the previous slide, we have learned that acceleration time graph, the area under the acceleration time graph gives the change in velocity. That means you can say that area under the curve is to be 0. Area under the curve is to be 0, but this portion has some area, some positive area. So for the area to be 0, there must be an equivalent area in the negative direction as well. So this negative area will be something like this. So for the exact area to be 0, this area, let's suppose, is A1. So this area should also be A1, because the magnitude of the two areas must be same, and that will be same if this is 10 and this is, again, this portion is 4. So this will become 8. Are you getting my point? The whole area should be 0. So this positive area must be equals to the negative area. So negative area should be a image of the positive area. So that's why this distance is 4 to 4. That means 8, and this is 10. So what is the time when the velocity becomes equal? That is t equals to 8 seconds. So at t equals to 8 seconds. This is the question which is very easy to understand. But if you don't know the concept, it is very difficult for you to solve. I hope you are getting the question. Now we will move towards the kinematics part, the kinematic equations, the today's topic. So today's topic is kinematic equations. First of all, I hope everybody knows that what is acceleration. Now, I will give you some important things about acceleration. Let's suppose what is acceleration. Everybody knows that acceleration is change in velocity over time period. This is no different, no difficult thing. Now, listen to me. What is the unit? You will say, sir, unit is meter per second square. Very good. Now, the thing that I am going to tell you, you should understand that acceleration means how much velocity is changing in a unit time. How much velocity is changing in a unit time. That means if some acceleration is given, I am talking about some examples. If acceleration is given as 2 meter per second square, that means in 1 second, its velocity will increase by 2 meter per second. In 1 second. So in 2 seconds, its velocity will increase by 4 meter per second. And in 10 seconds, its velocity will increase by 20 meter per second. Are you getting my point? What is the meaning of this acceleration 2 meter per second square? Is its velocity is increasing by 2 meter per second. Are you getting? In 1 second, it's getting increased by 2 in 1 second. Now, similarly, if I say you have heard the term negative acceleration, which is also known as retardation. I will ask you few very small questions after this. So, what is retardation? So, if I tell you, give you a clear picture, when acceleration is opposite to velocity, that means particle is moving in the right direction and acceleration is in the left direction. Then this is known as retardation. It's not like acceleration should always be in the left direction. For example, if particle is moving in the left direction and its acceleration is in the right direction. So this is also a negative acceleration. Are you getting my point? This is also a negative acceleration, or you can say retardation. So what is the meaning of retardation? The meaning of retardation is again similar. What it say, for example, if I say acceleration is minus 2 meter per second square, that means velocity of the particle will decrease by 2 in 1 second. For example, let's suppose if particle is moving with some velocity 10 meter per second and acceleration is minus 2, after how much time it will stop? After how much time it will stop? Can anyone answer? Without using the kinematic equation, the first kinematic equation you are going to use. I'm not asking you to use that. After how much time the particle will stop? Be quick in responses. Its velocity will increase by 2 meter per second, will decrease by 2 meter per second, 3 seconds. So to decrease by 10, it should take 5 seconds. Is it clear? So after 5 seconds, it will stop. Can you see these things? Can you see these things? You should know, and these things are applicable in the numerical section every time you use. So is the concept clear? Say yes or no. After that, I will move further. So I will name a few: Dahod, Ahmednagar, Bhavnagar, Raichur, and there is some mobile number actually. Name is not mentioned. JNV Bhandara as well. So you should answer. Everyone should answer. Is the concept clear? Now, after this concept, I will move towards kinematic equations. Okay, Bhavnagar is saying yes, sir. Now, everybody knows the kinematic equations. So I am just going to write the kinematic equations. First equation is V is equals to U plus AT. Second equation is, you know that, or I am writing it as X x minus x naught is equals to ut plus half at square. This x minus x naught is called as final position minus initial position. And this final position minus initial position is generally termed as displacement. So S is equals to ut plus half at square. Third equation is v square is equals to u square plus 2as. Or S is what? Displacement, which can again be written as x minus x naught. So you can write it as v square equals to u square plus 2a x minus x naught. So in these three equations, what are the terms that you should know? I hope everybody remembers. U is what? Answer yourself. U is what? V is what? A is what? X is what? X naught is what? So I'm starting from the last. That is x naught is what? Initial position. X is what? Final position. Be responsive. A is what? Acceleration. V is what? Final velocity. U is what? Initial velocity. Very good. JN with the hood. U is initial velocity. Now, after describing these terms, there is one more relation that you should remember. What is the relation? Or I will say fourth relation. Displacement in the any nth second or some tth second. That means they will ask you the displacement in the fourth second, not in the 4 seconds. They are asking you the displacement in the fourth second. So for that, the displacement is u plus half a 2t minus 1. This is again a very important relation, and you should remember this relation all the time because this is asked in a lot of questions in the exam. So I hope this point is clear. You can remember all these equations, out of which my favorite equation is the second one. It is used most of the times. And this equation is not, you can do these things in your mind without without writing the equation. So on this note, I'm going to start, just write down the equations and I'm going to start this. Okay. So this is first question, which is very interesting actually. First of all, I will give you some how much seconds? Some 30 seconds I am giving you to solve, and I need answers from everyone. Everyone should answer. Be quick. Nobody is answering in the YouTube. I don't know why. People are watching there on YouTube, but they are not answering. Okay. Are you solving the question? Raichur, Bhandara, Bhavnagar, Dahod, Ahmednagar, and is this Kadapa? Okay. So, okay, someone has answered B, that is 20 meter. Raichur has answered option D. Kadapa is saying option D. Okay. Okay. Now listen to me. First of all, the first thing that I will tell you, just listen to me and confirm me whether the thing is clear to you or not. First thing, listen to me. The whether tell me the acceleration is positive or negative. Just tell me this one. And I will solve the question after you answer. Tell me whether acceleration is positive or negative. Is it retardation or positive acceleration? Answer. It's negative acceleration. Everybody says that means acceleration is negative. Now listen to me. Its initial velocity is 10 meter per second and retardation is 2 meter per second square. What does it mean? Ki after how much time the particle will stop, the block will stop. After how much time? So from simple calculation, you can say in every second, its velocity decreases by 2. So in 5 seconds, its velocity will become 0. Is it so? So after 5 seconds, let's suppose the particle is, I am replicating it with some particle reference. Particle is moving in the positive direction and after 5 seconds, t equals to 5 seconds, its velocity will become 0. Say yes or no. Now, this particle still has some acceleration in the left direction. Are you getting my point? This particle still has some acceleration in the negative x direction. So this particle, जिसको मैं अगर हिंदी में बोलूं ये पलटी मारेगा. पलटी मारेगा मतलब it will return back. It will return back like this. So this is the actual process which is happening. Are you getting my point? And the question is asking again for the distance, not for the displacement. They are asking for the distance traveled. So what you should do, for the first 5 seconds, 0 to 5 second particle is moving in the positive x direction. In the next 5 second particle is moving in the negative x direction. So you should solve the question by breaking it in 2 time zones. That means first I will solve it for 0 to 5 seconds. Do you understand why I am solving by breaking it? Because the particle is changing its direction while motion. Is it clear? So now if I say what is going to be the distance, if I want to calculate the displacement, then there is no need to do this all these processes. So 0 to 5 second distance is, we will say s is equals to ut plus half a t square. Just put the values. S is equals to u is what, 10 meter per second. Clear. Time is what, 5 seconds. Now acceleration, you can see this is negative acceleration, that is minus half. Acceleration is 2 and time is square, that is 25. This can be cancelled. 50 minus 25, that is 25 meter. I hope till now everything is clear. This is the first breakup, that is, you can say s1 distance from in the forward direction. Now what we should do for the time 5 to 10 seconds. 5 to 10 seconds, if I talk about, again, if I use the kinematic equation, s is equals to ut plus half a t square. This is s2. What is the initial velocity from 5 to 10 seconds? Can anyone answer? What is the initial velocity for the motion 5 second to 10 second? 0. Very good, JNV Bhavnagar. So initial velocity is 0. Now, one more question that I want you to answer, whether in this 5 to 10 second motion, acceleration we will take as positive or negative. We should take acceleration as positive or negative in this second motion of 5 to 10 seconds. Just answer this question and we are done. Positive. Very good. Bhavnagar is saying positive because motion, the direction of motion and the acceleration both are in the same direction. That means half, acceleration is 2, time is again 25. 5 square is 25. So can you see that S2 is again 25 meter? So what is the total distance traveled? Total distance S is S1 plus S2, or you will say that is 50 meter, which is correct option number C. Now, what is the conclusion? What are the learnings that you can take from this question? Why I have put this question in front of you as a first question? That whenever you see some question of acceleration, retardation, anything, especially the retardation type of questions, just look for the time at which particle is moving stop, at which particle stops, and you can directly check it in your mind. Like I have checked it that after 5 seconds it will stop. So the first thing that you should do is to check whether the particle or at which time the particle will stop. Now listen to me, one more variation in this same question. I hope you can understand the variation as well. I hope you can understand the variation as well. For example, you have studied the question of the car moving with certain velocity and brakes were applied in the car. So the question is, let's suppose there is a car. Okay, before moving to the next question, is this particular question clear to everyone? Say yes or no. Is this particular question clear to everyone? Should I move further for the variation of this question? Nobody is responding. That means question is not yet clear. Okay. Only Bhavnagar has the clear cut answer. Only he is responding, or they are responding, not anyone else. So I am just going with the variation. Just try to listen. Let's suppose there is a car. I don't know whether how bad it is, but this is a car, Ferrari kind of car. So this car is moving some, let's suppose, certain velocity 20 meter per second in the horizontal direction like this. And suddenly the driver applies brakes. So when he applies brakes, the acceleration that is produced or the retardation that is produced is 5 meter per second square. Clear? The retardation which is produced is 5 meter per second square. So can you say that this is retardation that is negative? Now the question is asking you to find the distance traveled by the car before stopping, or no, they are not saying like before stopping. They are asking you the distance traveled by the car in 7 seconds or in 8 seconds. They are asking the distance traveled in, let's suppose, 7 seconds. Clear? So what's the problem here? You can clearly see that the car will stop after 4 seconds. Can you see this? Because initial velocity is 20 and retardation is 5. So after 4 seconds, car will stop. So the remaining 3 seconds, car will not move. Remaining 3 seconds, car will not move. Are you getting my point? In this particular question, they are not talking about the car. They are not talking about the brakes. They are talking about the particle. So this acceleration is constant. So particle will come back. ये पलटी मार लेगा. But the car, if you have applied brakes, you have pushed the brakes, it will not return back. So for the rest of the 3 seconds, it will not move. So for that, you will calculate for 0 to 4 seconds only. There is no need to calculate for next 3 seconds. So you need to identify whether the particle is given or the car is given. If they are given, they have given a car and brakes were applied, then it will not move for the next 3 seconds. Are you getting my point? So this is the variation. Not always do the same things. This is physics. You need to understand the things. Think practically. Is this point clear? For the rest of the 3 seconds, car will be at rest. Now, this is again the most wonderful question, I will say. It will open the mind. Very good. JNV Bhavnagar. Take some time and I will give you some 40 seconds to answer this question. This is again the same concept. First of all, they are talking about some east and west. Clear? So everybody knows that this is east and this is west. Okay, someone has answered option B. Option B is 0.5 meter. Okay, who has answered? JNV Raichur, very good. Okay, answer everyone. I'm not saying JNV Raichur that this option is correct. I'm just saying that you have attempted the question and you have answered. That's why I'm saying very good. Whether it is correct or not, it will be decided. So this is east and west. So according to the question, if I draw, a particle has an initial velocity of 9 meter per second due east. That means particle is moving. Suppose this is the particle and it has some velocity 9 meter per second in the east direction. Very good. And a constant acceleration of 2 meter per second square in the west. That means acceleration is in the west. Again, you can see that this is the case of retardation. The distance covered by the particle in the fifth second of its motion. Now, when they are talking about fifth second, what does it mean? They are talking about 4 to 5 seconds. Fifth second is what? After completion of fourth to 5. The distance we need to calculate during this time period only. Okay. Now, as soon as I see there is a retardation type of concept, first thing that will come to my mind, after how much time the particle will stop. So you can see that particle is moving with some velocity 9 meter per second. So it will stop after how much time? Can anyone answer? It will stop after how much time? You should answer quickly. After how long it will stop? Okay, still waiting. After how long it will stop? These are the things you should do in your mind. Still waiting. Amravati has joined. Kolhapur, good to see you again. JNV AMT, Jalgaon is also there. Vishakhapatnam is also there. That's really good to see all of you. So can anyone answer after how much time the particle will stop? It's moving with 9 meter per second. Acceleration is 2. So after 4.5 seconds, it will stop. So what you can see, it will move, continue moving. And after 4.5 seconds, here, this is the time 4.5 seconds, it will stop. And after this 4.5 seconds, they are again talking about particle. This is not a car, so it will return back in the direction. So it will again return back. ये पलटी मारेगा फिर से. Like this. This is going to be the motion of the particle. Now, we are interested in the calculation of the distance from 4 to 5. So can anyone predict that first of all, we should break it for 4 to 4.5 and then 4.5 to 5. So we need to break this motion in two parts. What are the two parts? One is 4 to 4.5 and another is 4.5 to 5 seconds. That's what we should do. So first of all, I will do this 4 5. And again, if I say, just answer me one thing. There were a lot of schools are there. Just answer me one thing, that at t equals to 4 seconds, what will be the velocity of the particle? At t equals to 4 seconds, what will be the velocity of the particle? Without using kinematic equation, you need to answer. What should be the velocity of the particle? Your responses are very slow. At t equals to 4 seconds, its velocity will be what? It was 9 initially. Retardation was 2. So in 4 seconds, it will decrease by 2 4 is 8. So remaining velocity is 1 meter per second. Is it so? So if its remaining velocity at 4 seconds is 1 meter per second, so you can use the kinematic equation to calculate the distance. So S is equals to what? Ut plus half AT square. Let's suppose this is S1. So S1 is what? U is what? 1. Time is what? 0.5 second. 4 to 0, 4 to 4.5, 0.5, that means it is 1 by 2 plus half. Acceleration is what? 2, and which is negative acceleration. So I will use minus directly. And t square is 1 by 4. 2 and 2 can be cancelled. This is 1 by 2 minus 1 by 4. So this is 1 by 4 meter. This is the distance traveled in 4 to 4.5 seconds. Now I will talk about 4.5 to 4.5. That means S2 is equals to, again, I'm using the equation ut plus half at square. U is what? At this time, velocity is 0. That is 0 plus half. Acceleration is positive in this case, that is 2. And T is again 1 by 4. So S2 is again 1 by 4. So what is the total distance? S is equals to S1 plus S2, and total distance is 1 by 2 meter. 1 by 4 plus 1 by 4, that is 1 by 2 meter, which is correct option, that is 0.5 meter. Again, I'm asking you, is this question clear to you? That is 0.5 meter. These are not the easiest question that you can do in your CBSE board. These are a little bit of higher level question. You need to think, you need to build your thinking for the JEE exam. And all these questions are PYQs. I'm again telling you. Now say yes or no. And I will move further after that. So we have done 2 questions of the same kind. Moving further. So we have 2 more questions here. Okay, let's start with this question. I will do only one question. This is your homework. You can do it in your homework. Take a screenshot and just do it in your homework. Same kind of question there is, and I will do this question for you. This is very interesting. The same question, language is same. So we are not going to solve 2 questions of same type again. So what it says, a car and a truck move in the same straight line at the same time from the same point. That means they are the thing they are talking about, that there is a car. Let's suppose this is the car. No, this is the road actually. On this road, there is a car. Yeah, there is a car and there is a truck, I will say. They both start at the same time in the same direction. Now the car moves with a constant velocity of 40 meter per second. The car is moving with 40 meter per second, and the truck starts. Starts means initial velocity is 0 with constant acceleration 4 meter per second square. The truck is starting with 4 meter per second square. Find the maximum distance between them before they meet each other. So now the previous question on the previous slide, they were asking when they will meet each other. Now they are asking the maximum distance, the maximum separation between them. Okay. So for that, you need to understand that why maximum separation. Can you see that? Initially, just listen to me. Just try to understand the situation. Initially, the truck has 0 velocity and the car has some velocity 40 meter per second. But the truck is accelerating. Its speed is increasing. Can you see that? So can you again see that the maximum separation between them? Can you see that the separation between them will keep on increasing? Because car is moving with faster speed, truck is moving with some slower speed because it's just started. So until the velocity of both becomes equal, until the velocity of both becomes equal, the separation between them keeps on increasing. But once the velocity of both becomes equal, now this is the time when separation is maximum. And after that, truck will try to cover up this separation, and ultimately it will catch the car. Are you getting my point? So its initial velocity is 40 meter per second. After how much time truck will acquire the same velocity? Can anyone tell me? After how much time truck will acquire the same velocity? You can answer. After how much time truck will acquire the same velocity? 10 seconds. Very good. Only Bhavnagar is responding. That's really, really difficult thing to digest actually. I don't understand why you are not responding, because its initial velocity is 0, acceleration is 4, it is gaining the velocity 4 meter per second every second. So after 10 seconds, it will be 40 meter per second. So you can clearly see that at t equals to 10 second, this separation will be maximum. Now at t equals to 10 second, what will be the separation? In t equals to 10 second, distance moved by the car. So what is separation? Separation is what? Distance. I'm not writing moved. You can understand distance by car minus distance by truck. Can you write it this way? This is the separation. Now distance moved by car is what? You can say car is moving with constant velocity, that is 40, and t. This is the distance. Distance equals to speed into time. I hope you can understand this. Distance moved by car is what? 40t minus distance moved by truck. Truck is moving with acceleration, so distance is s equals to ut plus half at square. But initial velocity is 0. That means only half a t square. Now put the values. You know time is 10. That is 40 into 10 minus half acceleration is 4. T is 10. 10 square is 100. Clear. So that is 400 minus, you can see 200. So what is the distance? 200 meter, which is again option number C. Are you getting my point? So the main thing that you should understand is t equals to 10 seconds. This is the base of the question. After that, everything is just simple mathematics, nothing else. So what you should understand, until the velocity of both becomes equal, the car is moving faster, so the separation will keep on increasing. Once the velocity becomes equal, now they will move with constant separation, and truck will start overtaking. So that's what the question is. Now again, moving further for the next concept. I hope this is clear. Answer C is correct. Now we are talking about motion under gravity. Till now we were talking about horizontal motion. When car is moving, particle is moving in the horizontal line on the ground. Now the particle is starting moving in the vertical direction. Or still I am talking about 1D motion. I am still talking about 1D motion. I'm not talking about 2D motion. So what are the sign convention that you should consider? I'm repeating my word. Whenever I am saying the sign convention, that means I am talking about vector quantities only. I'm talking about vector quantities only. One thing that is very much frustrating, that you are not responding. I can't get you that whether am I audible or not, or what kind of things happening here. So try to be responsive actually in the class. Okay. Sign convention. We are talking about vector quantity. So this is my sign convention. In your classroom, you may have taken some other sign convention. So I'm not saying only I am right. Some other person may be right. So what is my sign convention? That whenever there is a vector quantity, I'm talking about vector quantities only, is going upward, I will take it as positive. And whenever a vector quantity has its direction in the downward direction, I will take it as negative. As simple as that. The vector quantity which is in the downward direction, I will take it as negative, and the upward direction, I will take it as positive. For example, I will say there is a ball, and if I am throwing it in the upward direction, I am throwing it in the upward direction with some velocity u. So the velocity is a vector quantity, and this velocity is in the upward direction. If this velocity is in the upward direction, that means I will take it as positive. Clear? And another thing that I will say, let's suppose I have thrown a ball in the downward direction. I have thrown a ball in the downward direction from the top of a building, from the terrace. That means I have thrown it in the downward direction with some velocity u. This velocity is in the downward direction, so I will take it as negative. One thing is clear. Now, in both the cases, whether ball is going upward or ball is going downward, you can see that Earth is pulling it in the downward direction. Earth is pulling it in the downward direction, and the acceleration that is produced by the Earth is acceleration due to gravity. Acceleration due to gravity. And in both the cases, this acceleration due to gravity is negative, is in the downward direction. So, in both the cases, acceleration due to gravity is negative. So, what I will say, G in both the cases, I will take as negative. Is this whole concept clear to you? Ahmednagar, Raichur, Bandara, everything clear till now? In your classes, I can sense whether you have studied that when particle is going upward, take G negative. When particle is coming downward, take G positive. This is the concept you might have learned, or few of you might have learned the same way. But the thing I am telling you, do stick to that only. That acceleration due to gravity is downward. All the scenarios, so I will take it as negative. Rest is very much simple to you. Now, moving further. So, how the kinematic equations will look like? Generally, how the kinematic equations will look like? First equation that I will say, V is equals to, I am writing the general equations. I am not considering the particle is going upward or downward. But the one thing that is to be sure, that acceleration is always negative. So I have put A as minus G. V is equals to U minus GT. Second is S is equals to ut minus half gt square, and third is v square is equals to u square minus 2gs. Clear? S is what? Displacement. Now, after considering this thing, one thing that will again bother you all, that how to write the displacement, whether it will be positive and when it will be positive, when it will be negative. So for that, I am giving you some tricks to remember the things. Okay. These are the three questions that you will answer after the punchlines. So first punchline on your screen is, if final position is above initial position, then you will take displacement as positive. Are you getting my point? If final position is above the initial position. Just listen to me. In this question, particle is thrown from A in the upward direction. So this is final position and this is initial position. Can you see that final position is above the initial position? So displacement is going to be plus h. What is the separation is h, and this is going to be positive. Okay. What is doubt? HP occurred. This is the full form of HP. Okay. What is the doubt? Just ask me the doubt. I'm listening. Okay, just ask me the doubt, and till then, after I'm moving further for the next punchline. Next punchline is if final position is below initial position, then S will be negative. Now, in the second question, you can see that ball is thrown from A, YG is placed in place of acceleration. Okay, very good question. Whenever the particle is moving under the influence in the vertical direction, or I will say, the earth will try to pull it. The force applied by the earth on the previous slide, I will discuss it. The force, for example, particle is this, and this is our earth. This is our earth. So the earth will exert some force on it. Let's suppose mass of the particle is m. This particle is moving whether upward or downward, doesn't matter. The force applied by the earth on it is mg. This force mg, and from Newton's second law that you have studied in class 9th, I say force is equals to mass into acceleration. Clear? So force is what? Mg is equals to mass into acceleration. So mass and mass gets cancelled. So acceleration is g. So what I'm telling you that whenever the particle is moving in the vertical direction, the acceleration is g. But due to the direction, I have taken it as negative g. I hope it is clear. Very good. Now, in the second question, particle is thrown. Very good. You're welcome. Particle is thrown from A and it is moving something like this, but finally it is at B. This is the final point. Can you see that final point is below the initial point? So what will be the displacement? First of all, the distance between these two is h, but displacement will be minus h because final position is below. Can you answer this question? Let's suppose this distance is h. Can you answer what will be the displacement in this question? In the third part, what will be the displacement? Simple. This is, you can see the arrow, minus h. Very good. So displacement is minus h again. Very good. So after doing these three questions, I will solve one more question for you. Okay, one more punchline that I will tell you. When a ball is thrown vertically upward, for example, very good, Vishakhapatnam. For example, what I am saying, the ball is thrown vertically upward like this. So what will be its path? It will go upward, upward, upward until a point when its velocity becomes zero, it will return back. It will return back. So this is going to be its path. I have shown it that it has fallen some distance other. This is nothing. This distance is negligible because it has fallen over the same line. So what is the conclusion here? Let's suppose this is point A, this is point B, and returns again to point A. So the statement is time of rise is equals to time of fall. Let's suppose it has moved to A to B in time T1 and returned back in time T2. So T1 is equals to T2. That means time of rise is equals to time of fall. One thing you should remember. Second thing is velocity at same horizontal level will be same with opposite direction. That means again, if I can draw, let's suppose I have told you that this is thrown with 10 meter per second. So at the same point, when it returns back, its velocity will be 10 meter per second, but in the downward direction. Similarly, at this point and this point, velocity will be same. At this point and this point, velocity will be same. At the same horizontal level, velocities will always be same. Is it clear? So these were the punchlines. Can we solve one question? Say yes or no. Can we solve one question before ending the class? Very good. So we are going to solve one question at least. Very good. Time of ascent is equals to time of descent. The same thing. Very good. Vishakhapatnam. The question is, there is a building. A building is looking a 3D building. Very good. There is a building. A ball is thrown vertically upward with velocity 20 meter per second. So time taken to hit the ground. So one thing that you should know, that ball will go something like that. It will rise and then ultimately it will fall to the ground. Is it clear? Okay, someone has answered 5, 4, 2 answers are there. So what you should do, calculate the time. Very simple question. S is equals to ut plus half at square. Now, this is the general equation. If you write it in terms of kinematics or motion under gravity, you will write it as ut minus half gt square. What is the displacement? Final position is below the initial position, that is minus 25 is the displacement. Initial velocity is in the upward direction, that means 20. Time is t. Minus half g is 5t square. Always try to take g is equals to 10. If you take g 10, it will become 5t square. Now you can form a quadratic equation. It will become, you can divide it by 5. T square minus 4t minus 5 equals to 0. This is the quadratic equation. Now you can solve it. 5. So that is minus 5 plus 1 are the, if you do the product, 5 ones are 5 and reverse the sign. So that is 5 minus 1. These were the two answers. I have solved the quadratic in a very shortcut method. I will teach you how to solve the quadratic in such a small time. That 5 comma 1 is the answer. Time can never be negative. So 5 seconds is the answer. So which is option number D. 5 seconds is the answer. Is the question clear? The basic thing, the displacement we have used, the velocity we have taken positive, we have taken g as negative. So all three parameters, three punchlines that we have learned, I have used here. Now the next question will be some difficulty level will increase from these questions. So try to come in the next class. And till then, just do this question in your homework if you can solve. And on this note, I am ending the session, and try to join the class just before time or before time so that you can grasp the things, you can recall. I can ask you about the homework as well. So on this note, I am ending the session. Bye everyone. I hope you learned a lot of things. Thank you, students. Bye, bacha.